out here it will be basically on deriving river network, catchments and watershed delineation from DEM in QGIS. The DEM can be derived or extracted from NASA, UHS Earth Explorer, Copernicus Hub, and then etc. And then I hope you know how to download this kind of data. So before calculating the or generating the river network, catchment, and then watershed, first of all you have to assure that your DEM is in projected coordinates. So in order to identify whether it is in geographic coordinate or in projected coordinate, first of all you will click on DEM and then go to its properties. Then you will look at the information out here. So you can see the name as CPSC 4326, WGS 84, and then units in geographic, that is latitude and longitude, and type is geographic 2D, method latitude longitude. So in order to do an analysis, it has to be converted to projected coordinate. To do that one, you will go to raster, conversion projection, then wrap projection. So you will select your input DEM and then you will select the target, that is WGS UTM zone 45, and that is for Bhutan. So I am selecting this one because I am working for Bhutan. Then you can run. Now it will be in projected coordinates, and then you will see, not still, sometimes the elevation will have negative values, which means there are either sinks or the depression is still occurs out there. And then to fill it up, you will look for fill sink in processing toolbox. Fill sink, Wang and Lee. So you will select your DEM and then just click run under terrain analysis, hydrology, fill sink, Wang and Lee. So if you don't want this flow direction, you can uncheck flow direction, fill them. Okay, then flow direction, I don't want flow direction and I don't want watershed basin as well, and then you can run and then close. Now you have the fill sink, so you can compare the data between them. So it starts from 0, where in your original DIM it starts from -19, and then I am pretty sure that the elevation will not be measured using negative values. So you can remove your original DIM and then keep your fill dem. So now you will use your fill dem for the rest of the analysis. So once you run the fill sink tool, then you will look for Strahler, Strahler order, which is under terrain analysis channel. Click there, and then your elevation will be fill dem, and then you can run and then close. So now you will have the Strahler order, meaning you will have the order of stream in the raster format. So this raster format has to be converted to vector file format in order to derive the river network and catchment and watershed. Therefore you will look for channel network and drainage basin. So your elevation will be fill them. Then threshold, you can select the threshold as per your need. So higher the threshold, you will get maximum, what you call, if you select threshold as 4, then you will have the smallest example stream order in your when you derive the river network. So I don't want flow direction, I don't want sub-basin, flow direction, flow connectivity. Also Strahler order is not required. I don't want drainage basin, I am just interested in channel. You can just check channel, and rest of the field you can uncheck and then click run, and then you can close. It will take some time, and then your channels will be ready out here. So now you can see the channel in the vector file. So you can see the river networks. We have derived the river network. Now to derive the watershed or the river basin, so you have to create or assume your outlet point, meaning all the streams will accumulate in one of the area or in one of the location, and then it will outflow to rest of the direction. All the dendritic patterns, not dendritic pattern, the tributaries, all small tributaries will be accumulated in one of the location, and then it will outflow to other areas. To do that one, you have to create a point layer shapefile. So in order to create a point layer shapefile, you go to layer, create layer, and then create new shapefile layer. Name it as port point, and the geometry type should be point, and then your CRS should be WGS UTM zone 45N. Name it as maybe name, and then just add it, and then click OK. So your PowerPoint is out here. So I want to demonstrate for maybe Amochu. Yes, Amochu. So out here, is this the one? Okay, somewhere here. So I can see Amochu out here. So I want to create a PowerPoint for Amochu. So to create a PowerPoint, you click on your point shapefile layer, and then you will activate the toggle editing, and then add point feature. Then you will go to Amochu out here. So before assigning a point, you have to check your stellar order. So somewhere my Amochu is somewhere here. So click on stellar order, come here, and then add your point. Name it ID number 1, and then name as Amochu, and then click OK. Once you do that, your point will appear there in your there as a port point or outlet point. Just uncheck this one, and then you can see out here your PowerPoint has been created in the border to India of your Amochu, meaning all the tributaries will accumulate it out here for Amochu, and then will outflow to the other direction to India, maybe, to make it simple. Then after that, you have to create a river basin or watershed. Therefore you will look for upslope. So you will click on terrain and hydrology upslope, and then you have to assign the target area. So for target area, you have to assign XY coordinate. So XY coordinate will be the XY coordinate of your PowerPoint. And then I have already calculated the XY point out here, and then I am pretty sure that you know how to calculate the XY coordinate. There are two options. First of all, you can create a new field, example XCORD, X code, and then it should be decimal number. Okay, then again do the same, that is YCORD example, and then select decimal number, click OK. Then you can go to field calculator. So here are the options. If you have not created a new field, you will create a new field out here, name it X coordinate, Y coordinate, and then go to geometry. You will select $S, but I have already created a new field out there, so I will select the existing, I will click on existing, update existing field, and then select the field that to be updated. So I want to calculate X coordinate. So to calculate X coordinate, you will select $X, and then to calculate Y coordinate, you will select Y, $Y. So this is my X coordinate, will be, then Y coordinate y coordinate. So your elevation is filled in. Then you will select the method as 0 deterministic 8, and then you can click run and then close. It will take some time, and then your upslope will be generated like this. So meaning these are the tributaries that are flowing to this major river, that is Amuchu, and then this is the accumulation point or the outpour point or pour point. So after that you have to convert this raster, your upslope, into the vector format, and then you go to raster conversion, polygonize raster to vector. So your input will be upslope area, and then you don't have to do anything, just click run and then close. So you will get your upslope like this as vectorized.